Hello, everyone. Thank you for tuning in on a Sunday afternoon or morning or evening, wherever you are. My name is Ashley, and I'll be co-leading today's session with Sim. I'll be covering strategies on physics passages and guiding you through a very straightforward circuit elements passage, so we might not even take up the full hour. These weekly passages will cover concepts that were discussed in the previous week's topic session. So this week, we held a circuit elements and a gene expression topic session. So this practice session won't go into depth about concepts because we're assuming you attended or watched the recording of the topic sessions from earlier this week. So this is an overview of what we will be covering today. I'll start with going over some strategies on how to tackle a physics passage. Then we'll jump into the circuit elements passage and then into the gene expression passage. Just a disclaimer, the passage for circuit elements isn't that conceptual. It is more so dealing with equations. And this is because, one, I wasn't able to find a more conceptual complex passage. And that is because the MCAT physics portion, particularly the circuits topic, is more so being able to manipulate and recalling equations. Yes, we are recording the session. I remembered this time. Okay, so physics passages are not at all like the physics 1 and 2 courses that you took in college. While it does help to have taken these courses before the MCAT, you absolutely can do just fine by self-studying. The physics passages on the MCAT, at least the ones that I've come across, are rarely complex, difficult questions that take 20 minutes to solve. The MCAT only wants to test you on your ability to apply equations based on what information they're giving you. That being said, I do recommend that you have equations memorized. What I did was that I made a master list of all of the equations covered on the MCAT and wrote them by hand every single day. You can also make flashcards or anything to help you know these equations by heart. And if you guys want, I can send you a list of the equations that I memorized in the post-session email. So let me know if you're interested in that. So when doing a passage, I also wrote equations that were relevant to the passage. So if it was a kinetic passage, I would write down the big 5 equations on my noteboard. This would help me save time by choosing which equation I would use more quickly. And because the test is on the computer, I would try to draw a rough sketch of any diagrams from the passage onto the noteboard so that I could annotate. This helped me for understanding the passage, and I'll elaborate on this in a bit. This is especially useful for those of you who are visual learners like me. I really depend on diagrams and drawings. So I also strongly advise against mental math. So this might be personal, but I can easily mess up when I'm trying to do mental math. So I like to write everything on my noteboard so I could be more organized. And you also want to generally spend about 8 minutes per passage, but the actual exam is kind of strange because you can come across passages that are only about like 3 or 4 questions long. But my main point is that if you are doing a very complicated multi-step problem, hit the red flag button and go back to it at the end. You don't want to spend too long on one passage. Like I said, the MCAT won't ask you to do crazy complicated math. And if you do, you need to round your numbers. The answer choices will generally be whole nice numbers. For example, instead of using 9.8 for gravity, you would use 10. And unless the numbers are simple or one digit, I would round up. Please send the question. Yes, okay. I will send the sheet at the end of the session. And let me send you guys the link to this passage. Can everyone see the passage? Okay. All right, so let me know if you're ready and I'll start the timer for 10 minutes. So remember to keep in mind the tips that I just said, including writing out equations or drawing a rough sketch of this circuit if it helps you. All right, I'm starting the timer now. Okay, that was 10 minutes. Is everyone ready? I actually have a question for you guys. Would you prefer doing the passage before the session or during the session? The reason why I had you guys do the passage during the session is because I wanted to time you so you could get an idea of what it's like to be under pressure a bit. But let me know if that's not helpful and we can change it up for next week. Okay, that is true. Okay, we can talk about it more after the session and we'll talk about it as a team as well. Okay, so who would like to explain how they answered this question? Would you guys like me to explain? Okay. So Kirchhoff's law is very important when answering questions about circuits. Kirchhoff's law states that the current flowing into a point in a circuit is equal to the current flowing out of a point. It also states that elements in series will have an equal current. So the question is saying that a current of 2 amps is flowing through a battery. So that's the total current flowing through the circuit. Once the current reaches this node here, where it branches off into R1, R4, and R5, it will divide according to the value of the resistor, so the resistance. The question says that 0.4 amps of current flows through R1 and through R5. So that's 0.8 amps of current total. Since the current entering the node is 2 amps, the remaining current that flows through R4 must be 2 minus 0.8, which is 1.2 amps. Does anyone have any questions about this or solved it differently? Is it okay if I move on to the second question? Okay. So what is the total resistance across R1, R2, and R3? Does anyone have an answer? Yeah, Brian, would you like to explain how you got it? Yeah. So an equation that you have to know is the total resistance equation, or equivalent resistance for resistors in series or in parallel. For resistors in series, the total resistance is the sum of the resistors. In this question, sorry, you are being asked for the total resistance across R1, R2, and R3. The circuit shown in the passage shows that these resistors are in series and that the resistance for each is 2 ohms. So to find the total resistance, you would add 2 and 2 and 2, so the total resistance would be 6 ohms. Okay. For the next question, would anyone like to volunteer? Oh, yes, you're correct. I messed up the units. I apologize for that. Okay, I'll just walk. I'm so sorry. Yes, B is correct, but the units I messed up. I'm so sorry. So with points 3 and 4 connected, the battery is now connected to this resistor network. The battery is producing a potential difference of 15 volts. The resistance of the resistor network is 10 ohms, and we are trying to find the value of Q, the charge, flowing through the network in 1 second. We can use the equation Q equals IT, so current times time, but we need to find the current I. And to find I, we will use the equation I equals V over R, so current equals voltage over resistance. The thing about MCAT physics is that most of it is just manipulating equations to find what you need. So we have values for V, T, and R, and we need Q. So we'll plug in the equation for I, the current, into the equation for charge, Q, and we get 1.5. So the unit would be coulombs. I'm not sure how I messed that up. I'm so sorry. Okay. Any volunteers? Yep, D is correct. Would you like to explain?
Sure. I just remembered the equation for power is voltage times current, and which kind of just equals to V squared divided by R, since you can substitute current with V divided by R. So I just ended up squaring the voltage and dividing by the power to get resistance.
Yeah, that's exactly right. So like I said, MCAT physics is mostly just rearranging equations to get what you need. So again, we have points 3 and 4 connected, meaning that the battery and the resistor network are connected. The battery produces a potential difference of 30 volts, as the question states, and the power is 3 watts. And if we recall, power in a circuit is the rate at which energy is absorbed in the circuit. So there are 3 equations for power, which are essentially the same thing, just rearranged. So you can find power using V and I, so voltage and current, but neither of these are what we're looking for. And if we remember the equation I equals V over R, so current equals voltage over resistance, we can substitute current for V over R. That way we're able to plug in our values for P and V to find R, our resistance, which will be 300 ohms. This is an example of why it's important to memorize the formulas and writing the relevant ones down on your noteboard, because it makes a question so much more easy to solve. Yes, what's your question?
I don't understand on the question 4, why can't we just add up the resistance as we did like the previous one? Is there any part on the, is any word on the question that indicate that we should not simply add up the resistance, but we should using the power formula?
So this is a different scenario in which the battery is producing a potential difference of 30 volts. And this question is asking you to look at the resistance network as one. So instead of adding up all the resistances, individual resistances to find the total resistance, we have to think about the situation that we're given. So the question is giving us a potential difference of 30 volts, and it's saying that the resistor network is consuming energy at 3 watts. So instead, so when you're answering questions about physics on the MCAT, you want to find like the easiest way to solve it. So if you're given these 2 values, you can manipulate these equations to find one value. And by these 2 steps, you could find what you're looking for.
Oh, because when I see the word total resistance, I immediately thought of like adding up, and I forgot the power formula for like at that time. But thank you.
Yeah, okay, no worries. Okay, anyone want to volunteer for 5? Yes. Would anyone like to volunteer?
Sure, I can go again if you don't mind. I just like
Okay.
capacitance in series, you have to add the inverse. Well, since they're like opposite with the resistor, that's just a formula that I remembered.
Yeah, exactly. So taking a closer look at C1 and C2, we see that they're in series. Another equation that you have to memorize is the one to calculate equivalent capacitance for capacitors in series. You also need to know the equation for capacitors in parallel. But in this problem, you will use this equation, 1 over C equivalent is equal to the sum of the reciprocal capacitances. So the passage states that the capacitors have a capacitance of 2 microfarads. The equivalent capacitance is then 1 over C equals 1 over 2 plus 1 over 2, which is 1 microfarad. And when you have an answer that is not 1, you will need to take the inverse of it because we're dealing with 1 over C equivalent. Oh, I'm sorry about that. So for our last question, would anyone like to volunteer? Yeah, C is correct. Do you want to explain? No pressure if not, I can do it. Yeah. Yeah, that's exactly right. So with points 2 and 3 connected, we have the capacitor network and the resistor network attached. We're given the total resistance, total capacitance, and the potential difference. So to find the energy consumed by the resistors, we need to use the equation for potential energy, which is a half Q times V. So 1/2 charge times voltage. We don't have the value for Q, but it does equal to capacitance times voltage, which we do have values for. So we substitute the value of Q for C times V, and now we're able to solve the problem. When plugging in the capacitance value, we have to remember to use the standard units. So we need to convert from microfarads to farads. That will give us 10 to the minus 6 times 10 to the minus 2 times a half. So that's 5 times 10 to the minus 5 joules. Like I said, that was the last problem. If you found some of these problems a bit confusing, I recommend rewatching the circuit elements topic session that happened earlier this week and to begin memorizing the equations for the physics portion of the MCAT, which I will give you the sheet for later today. So passages like these require practice so that you can become more familiar with the equations. And if there are no more questions, we can move on to gene expression. So we'll send you the link in the post topic session email. So can you guys tell me if this passage was too easy, too hard, normal? Just so I could get an idea of like what passages to pick for next time. Okay, great. Thank you guys for listening.
Hey guys, we're going to start the gene passage and I sent it in the chat. So let me know when you guys are ready and I'll start the timer for 9 minutes. Okay, you guys can get started. If everyone's ready, we can go over it now. So let me know in the chat. Okay, cool. Yeah, so this was a little off topic from the topic session, but this was the best I could find online, but we'll go over it now. So question 1, do you guys want to put your answer in the chat? Okay, yeah. So restriction enzymes, they cleave the nuclear DNA at specific restriction sites, and they allow for the sticky ends to then recombine. Okay. Number 2. Okay. Yeah, so cDNA is made from mRNA, which goes through reverse transcriptase to make the single-stranded DNA, and then DNA polymerase comes around to make the complementary DNA. And yeah, so it's made from an mRNA template. Number 3. So cDNA is complementary DNA. I don't think it stands for a copy.
I mean, when you make a replication of a DNA, could the complementary DNA mean like the non-template DNA?
Yeah, it's not the template DNA, but it's also not an exact copy. We'll go over it, but cDNA is different from the genome DNA.
Okay.
Yeah, for number 3, microarrays, this is kind of an example of what it looks like, but you collect the DNA sequence onto a solid surface, and it binds to these kind of like cell structure here. And if the gene is active, then the cDNA will bind to it and it will actually fluoresce. As you can see, like they are in different colors. So it kind of, you can get a lot of gene sequences and identify a lot of genetic diseases by using the DNA microarray. So this would be a good example of A. Number 4. Okay, yeah, so cDNA, as I was going over, is different from the genome DNA because since it's made from the mRNA, and mRNA removes introns as it goes through splicing, so the cDNA will also have that RNA processed and lack those introns in the DNA. So it's the DNA without the introns. Number 5. Yeah, so PCR, goes through a few steps, and the first one is denaturation, which heats the DNA to 90 degrees to separate the double strands, and this denatures it. And then annealing is when we cool it down, and then the primers anneal the single-stranded DNA, and then during elongation, we use heat to stabilize the polymerase and then extend the primers. So that's why we would need heat-resistant DNA polymerase so it can survive the denaturation step. Do you guys have any questions on this passage? I know this was fairly simpler than what we're used to.
I have a question.
Mhm.
So, when you mentioned that elongation step requires heat,
Mhm.
is it just like background knowledge we're supposed to have between B and D that the extent of heat is more in step?
Yeah, the denaturation. So this is a lot, like you get really hot to like kind of break apart the double strands and you denature it, but you need to have heat resistance so it doesn't, the DNA doesn't actually like, the DNA polymerase doesn't denature during this step. So it's still able to come back and anneal to this process. During elongation, we're just heating it up a little bit more to stabilize the polymerase to extend the primer.
Thank you. I also just want to say I appreciate that you guys threw in a different topic because I think like it's important to have randomized topics to review every now and then. So thank you for like, even though this was like a circuit thing, thanks for throwing in a recombinant DNA passage. I appreciate it.
Yeah, no worries. And yeah, we have some questions. Why was the passage there? Because the questions seem really not dealing with the passage. So sometimes it does happen like that, where there's a lot of kind of freestanding questions, and the passage is just there from background knowledge. But yeah, those questions could have stood on their own as well. This was just describing recombinant DNA and how it can be used in the field. Do you guys have any other questions?
Hi again. I actually have one more question.
Mhm.
So this is my first time using MCAT 101. So I'm just wondering, how do we get access to like previous recordings? Thank you so much.
Yeah, we send out a post-session email with all the links to the YouTube channel, and all of the recordings are up there so you can go back and rewatch them.
Thank you.
Mhm. Ashley, do you have anything else to add?
Yeah, so sometimes you will come across passages. I know that I did on the real MCAT where the content will not like pertain to the questions at all. So like Sim said, the questions could be like freestanding on their own. It's just eventually with more and more practice, you'll kind of train yourself on what information to look at and pay attention to. And then like on your own, you will like unconsciously, or I guess subconsciously, um, filter out irrelevant information.
Yeah, so we still have a couple more minutes. So if you guys want to use this time to ask us any other MCAT related questions, you can definitely feel free to do that.
Oh, and going back to what we were talking about before, do you guys feel that we should include more passages during these sessions and have you guys complete them before the session, or do you prefer doing the passages during the session? Okay, so we have 2 for before. Oh, we have more for before. Okay, so we have 5 for before and 2 for during. Okay, so I guess Sim and I will talk about it after the session and implement those changes for next week. A combination of both could also work.
Yeah, and I was wondering if we were to do maybe potentially, because I liked it during, but maybe if we were to, would it be possible? Let's say we covered 4 topics, and then those 4 that we have 4 passages that reflected the 4 topics that were discussed for that week.
Yeah. Yeah, so this week we only cover 2 topics, but usually we cover about like 3 or 4. So in that case, if it's like 4 passages, we could have you guys do 2 before and then 2 during. That way we could get in some more practice.
Okay, that would sound good. Thank you.
Yeah,
Okay.
thank you for your feedback.
I like the hybrid idea as well.
Okay, that's good to know. Thank you guys for your input. Okay, Sim, do you want to wrap it up or should I?
Yeah, we can wrap it up now, if there's no more questions. So just a reminder that we are volunteers and we would really appreciate if you guys could help us become a nonprofit. We're really close to our $500 goal, and that's going to help us become a nonprofit, and we could apply to more grants to get funding to keep this program running. And we really appreciate all the help and the support you guys have given us. So thank you for that. And if you have any questions, feel free to email us at mcat101questions@gmail.com. And look out for the post-session email. And that is all I have for today.
I have a question regarding the donation.
Mhm.
Yeah, so I tried last time to do it and it's not accepting like any of my cards. Do you have like any other way in which we can donate? Or
The
or
PayPal.
should I just try it again? Yeah, it's not working. Like I used like all my cards and it's just not letting me do it.
I have not heard
Yeah.
about that. We'll think of something then and let you know then.
Okay, perfect. Do you want me to send you guys an email like after just to
Yeah,
remind you?
that's fine. Yeah, thank you.
Okay, cool. Thank you.
Okay, well, thank you guys for coming, and we'll see you at a future topic session.
Oh wait, Sim, sorry, someone asked me a question. I'll just answer
Oh
it
yeah,
quickly
go
here.
for it.
So for the 6th question on the circuits passage, to get the formula for potential energy, it's a formula that you have to memorize, unfortunately. So potential energy is equal to 1/2 times Q times V, which is 1/2 times charge times voltage. But we have to substitute in Q equals CV for Q because we don't have that value, but we do have the values for capacitance and voltage. So this is another example of how the MCAT will ask you to have these equations memorized and being able to manipulate them to get what you want. Does that make sense? Okay, great. Okay, I guess that's all for today. Thank you guys for coming on a Sunday, and we can't wait to see you guys at the topic sessions this week.